Okay, how long have I got?
About 5 minutes.
Oh, come on, no one could build an arbitrary model of the relationship between wheat yield and climate and then fit that to data and make predictions in 5 minutes, right? Well, unless they have, which is a prototype research tool that we put together here at Microsoft Research. My name is Drew Purvis, I'm the head of the Ecology and Environment Group. You can go to this thing, it's just spinning up at the moment, it takes a few seconds to load itself in. Now what I'm going to do, I'm going to go to the first step in my analysis. I'm going to go and get a file. I'm holding that file on the SkyDrive, so I'm just going to go and find that thing, which is here. And so I've just done an action of importing that file into the browser, and that's created an object, which is a table containing that information. If I now go into that table, because it's very simple, it's just latitude, longitude, and the yield of wheat, just CSV table, very, very simple. First thing I can do is have a look at that data. So we're going to do an action called make chart. I'm just going to use some simple drop-down commands here, lon and lat, and as soon as I put lon and lat, the thing knows by default that you show that on a map, and so it's put it on top of Bing Maps. I can color according to the yield of wheat, and straight away we can have a look at the data. I can zoom in and out, change to aerial photo view, all that kind of stuff. Well, that's all very well, but what I want to do is relate the yield of wheat to temperature. So what I'm going to do is I'm going to go back to my workflow. We're building a workflow as we're doing this, back to the which keeps track of everything I've done. I'm going to go back to my file. I'm going to do a fetch climate step. What this is going to do is go down that table. It's going to use the latitude and longitude as a key to go and hook out the air temperature for each of those places. So now we can see a table here where we have the air temperature. We'll make another chart. And now we'll look at the relationship between the yield of wheat and air temperature. And what we can see here is there's a humped relationship, so the yield of wheat tends to peak at intermediate temperatures, which is something like we'd actually see here in Britain. Okay, that's all very well, but now what I'd like to do is define then a model, a scientific model that would capture that pattern. So I'm going to start again, go to this step called design model, and I'm going to type in wheat here. I'm going to pick a couple of small options, and what I'm able to do now is just using this point and click, define a relationship between the yield of wheat and air temperature. All very well, we can read about this. This is a humped relationship, which is the kind of thing I want, but it's really important to realize that I'm not restricted to just the options in the point and click. What's actually happening here is as I'm clicking those things, I'm actually building F# code on the fly in the browser, which is then being compiled and run. That means I could put any model whatsoever inside this box. It could be a complex model of the spread of ash dieback disease. It could be a complex model of global malaria spread, or any other form of model, even financial model, or anything at all. I'm just going to go back to the designer now. So that's all very well. Now I'm just going to pull just a couple of small options out here, which I won't bore you with. And we're nearly done now, and I guess we're nearly done on my 5 minutes too. So now I have this model, and what I'm going to do is take that model and combine it with the data that I had earlier. And that's in an estimate parameter step here. I need to supply my model, which I've done, my response variable, which is the observed yield of wheat, which is here, my environment, and then I've specified enough to run a fully blown MCMC Bayesian analysis, as it's called. And this for us ecologists, or computational ecologists like me, this is almost like the CERN particle accelerators, you know, the way that they smash particles together and get crazy stuff out. Or what we're able to do with this information technology is take ideas and data and smash those together to get incredible insights about what's going on and make useful predictions. So we've just smashed those together in the browser. This gives us a chain of parameters, as they're called. From those chains of parameters, we're able to analyze them. Have a look here, we can see the uncertainty on the optimal temperature for growing wheat. We can also then, and actually I can see that hasn't worked because I haven't run the step for long enough. So I'm going to go back to my provenance here, and I'm going to look at my estimate parameter step, and I'm going to run it for a bit longer. I think they had similar problems at CERN, right? It took them a little while to find the Higgs boson. So we're just doing a longer search for those parameters here, and hopefully we'll find an appropriate parameter step. And once I've got those, I'm going to extract my best set of parameters from those, and I'm going to then push those back through the model to do a simulation, which I'll do in just a second. So we're able then to look at our chain. We're able to analyze the chain, get a particular parameter set, which is still not looking too good, but I'm going to carry on regardless. I'm going to push this through to simulate the distribution. I'm going to use the same model as I used before, the same environmental data that I used before. And this is enough then to create some predictions, which I can also view on a map. If I just pick this one here, lawn, lat, and now instead of the real wheat yield, we're looking at the predicted wheat yield, which looks really bad, as I mentioned, because we haven't quite found the best set of parameters yet. And with all of this stuff together, I can then use this thing. So if I go back now, I can see all of the things that I've done here. I can go to my most recent chart, use it in a multi-view. There's panel 1. Panel 2, we can use the real OBS yield against temperature. Here we've got the yield on the map, the real yield. I'm going to zoom out a little bit from the browser so I can see these things a bit more clearly. What we're able to do now is have a look at all of these aspects of my analysis. They've all been tracked, so I can see everything I've done in the analysis has been tracked. If I change anything here, everything downstream will be updated. And finally, I can hit one button here and save that entire end-to-end analysis as a zip file. I can then close down my browser. I could email that to you. You could go to the same URL, read that zip file in, and you would have everything I've just done. And you could alter all the options I've done, change the model, change the data, etc. And so what this enables in theory then is us to go from the data through a complex model out to predictions with uncertainty, which is what we need to make decisions. And so it radically accelerates that, and then we're able to then collaboratively build those workflows, improve the models, loop back, ask what data we'd like, and improve the predictions. And that's something we can use across all different aspects of the work that we do in ecology and environmental science, but also it's a much more general story about sort of big data to big decisions in general. Thanks.